Greetings, everyone. I am Kang Ming Xuan from Industrial Mathematics, UTM. Today, I would like to present to you my final year project 1, which is on hybrid particle swarm optimization genetic algorithm for solving green vehicle routing problem in oil and gas industry. So why today Malaysia is selected as the refinery country and petroleum product exporter for this project is because, first of all, Malaysia is the fifth largest LNG exporter in the world, and Malaysia is the second highest petroleum producer in Southeast Asia. Another thing is 12.6% of the total export in Malaysia is actually from petroleum products. For the objective of our study, we will mainly focus on three things, which is first, to develop a multi-objective decision model to minimize fuel consumption costs and carbon dioxide gas emission. Second is to obtain the most optimal route through hybrid particle swarm optimization genetic algorithm. And the third thing is to assess the feasibility and practicality of LNG and HFO vessels. Next, we will look at the significance of study. So we will mainly focus on solving SDG 13, target 13.2, which is minimizing the greenhouse gas emissions. And we will also focus on tackling SDG 9, target 9.4, which the main objective is to minimize the carbon dioxide gas emissions. And now, let's look at the literature review. So for literature review wise, mainly we will focus on two things, which is particle swarm optimization, the search technique of optimization problems inspired by swarming behavior, and genetic algorithm, which is the evolutionary based computation technique inspired by natural selection. So once we combine both of their advantages, which is social thinking from PSO and local search from GA, we will get hybrid PSO GA. This is able to solve the green vehicle routing problem, which combines both vehicle routing problem and environmental objectives. Now, let's talk about the objective functions. So for objective functions wise, the first one would be mainly the objective function to minimize the fuel consumption costs. And for the second objective function, will be mainly tackling the minimization of carbon dioxide gas emissions. Now let's talk about the algorithm. So for our hybrid PSOGA algorithm, I will mainly propose this, which is the initialization of particles position and velocity randomly first. And next, we will evaluate the personal fitness value of each particle I. And we will do three things simultaneously at the same time, which is order crossover between the P-best, which is the personal fitness value, and the current value. And we will also do the order crossover between the G-best, which is the global best, and the current value. And we will also carry out a random mutation, which will randomly choose between swap mutation, inversion mutation, and scramble mutation. And next, we will assign and update best position fitness value for both the personal best and the global best. And we will check the termination criteria. If let's say we have not reached the termination criteria, then we will continue at the evaluate personal fitness value part, and we will keep on looping this until we reach the termination criteria. Once we reach the termination criteria, this means that we already obtained the optimal solution, and hence we can stop at there. And now let's talk about the preliminary results. So for the expected results, we will have three things, which is the crude petroleum, refined products, and liquefied natural gas. These are the products that will be exported to various countries from Malaysia. This will be the route, and this will be the best ship specification for crude petroleum, which is medium-sized ship with LNG vessel. Same for refined products. The best ship for this will be also medium-sized ship with LNG vessels. And for LNG wise, the large size ship with LNG vessels is the best selection. So this is based on the best results. And what can we get from the discussion here is, first of all, HPSOGA is able to find the most optimal solution based on the expected results right here. And the second thing is LNG vessels outperform all of the HFO vessels in minimizing both transportation costs and carbon dioxide gas emissions. And this model can be improved based on the future direction suggested. If you are interested to know more, feel free to scan this QR code and check out my final year project 1 report. And this is all from me. Thank you.